Hello everyone, welcome back to Year 10 Mathematics. My name is Victor, and today we're going to be learning about scatter plots, which is going to be the line of best fit. And to repeat our habits, we have balance the dots above and below. Interpolation is safe, extrapolation is dangerous. But what does that actually mean? So, box plots are great for a single variable, like test scores, right? But again, life contains a lot of variables. And what if we actually want to see two variables that are connected? Does studying more hours actually lead to a higher score or lower score? So we need to find that out. So to find that out, we plot bivariate data, two variables on a scatter plot. So as you can see here, I have a red line and a bunch of dots. As you can see, each dot on this graph is a single student. Its position on the x-axis shows that how many hours that they study, as you can see, going from 0 to 10. And each position on the y-axis shows that the score that they got from 0 to 100. So just looking by the swarm of dots, we can see a trend that it is increasing. Yes, it's going up. As the hours go up, the scores generally go up as well. And to make this mathematical, we draw a line of best fit, okay? So you want to balance the dots above and below. The line of best fits does not have to touch every single dot. In fact, it rarely touches anything perfectly at all. What you want to do is you want to draw a single straight line through the middle of the swarm, so that roughly half the dots are above the line and half are below it. As you can see, I've drawn in a way where a lot of the lines are above it, but I'm not like the best. Maybe I can draw it something like this. Yeah, this should look slightly better, but again, it's the same thing. I'm not I'm not the best at drawing. That's gonna be our line, okay? And once we have it, we can use it to make predictions. Suppose a student studied for, let's say, 5 hours. 5 hours, so we need to map out 5 hours here. 5. And we go 5 on the x-axis, go straight up until we hit our line of best fit. So as you can see right here, go across. It points to a score of around 60 to 70 or so. I hate myself for saying that. But again, I need to go with the lesson. This prediction is this is called interpolation. Okay, this is called interpolation because it is inside our existing swarm of data. Interpolation is generally very reliable. But what if there is some crazy nerd that is going to study for 20 hours or so? Now, if we extend our line, basically, if we extend our line, it will go up very long, of course. But again, if you extend this, then the score would have to reach something like, I don't know, like this is like 150 or so, but that's physically impossible. So again, that's extrapolation, making a prediction that is outside of our range of data and outside of the borders of our lesson as well. Now, extrapolation is dangerous, okay? You don't want to do this. You don't want to think about how this can be a real thing. Just do it within the realms of our current data, because real world trends eventually they will break down, they will curve, or they will hit limits. So they will eventually reach a point where this is actually they'll flatten out like this instead of actually being like this. Okay, so you cannot trust the line of the best fit forever. So to remind yourself of this, I have to remind, for today's habits, when drawing the line of the best fit, don't play connect the dots, just balance the dots above and below the line. You don't need to be perfect, and you just need to have a line. And when making predictions, always remember that interpolation right here within this box right here, doing data within that, is safe. Outside of this is very, very dangerous. I'll see you in the next video.